Okay, so let's have a look at this warm-up then. I'll do it on this page here. Oh, that had all the answers. Right. So what we're doing with this is, first of all, we want to get rid of this multiple angle. You must write this. We're going to put in this substitution, and writing this substitution is not optional. It's something that you must write on there. So we're solving for the cosine of theta equals the square root of 2 over 2, which, it's going to be much easier if we rewrite that as 1 over the square root of 2. It's the same thing. But when we did this, so what's our range going to be for theta? Well, theta is 3x. So if we multiply that by 3 times 0 is 0, but 3 times 2 pi is 6 pi. So when we're solving for this angle here, theta, we're actually having to go up to 6 pi. What we're going to do is we're going to have all of our answers between 0 and 2 pi. We're going to get those solutions first. Then what we're going to do is, to each solution, we'll add on 2 more pi, and we'll get a second set of solutions, which are going from 2 pi to 4 pi. And then to those solutions, we're going to add on another 2 pi, and that will give us answers from 4 pi up to 6 pi. This is for theta. And we're solving for theta. So let's have a look at this one. Theta, when we want the cosine of theta, the angle is theta. This is the ratio of x over r. And it's going to be a positive divided by a positive. Because this is positive, it's not going to be negative divided by negative, because r cannot be negative. Okay? So if x is positive, theta must lie in quadrant 1 or quadrant 4. And we know that x is 1 and the radius is square root of 2. So what I've just drawn there, those are 45, 45, 90 triangles. And I was solving for theta. Theta is the angle that takes you to the terminal ray. So it's that angle and that angle. And 45 degrees, that's pi by 4. So in quadrant, I've got 2 answers at this point, and the denominator is 4, because it's based on a 45, 90 triangle. Quadrant 1, it's pi by 4. In quadrant 4, it's 7 pi by 4. What I've just done there, these are answers in the range 0 to 2 pi. So I've done these ones. Basically, I've got here my triangles, and I've come up with that and that angle. For these, I'm going to have to add on 2 pi. To get from there to there, I'm adding on 2 pi. So for my answers in the range from 2 pi to 4 pi, I get each of those previous answers, like pi over 4, and I'm adding on 2 pi. Remember, when you're adding fractions, they need a common denominator, so 2 pi turns into 8 pi by 4. Pi over 4 plus 8 pi over 4 is 9 pi. So my first solution, that's this angle here, is 9 pi over 4. And my second solution in this second trip around the circle is this one here. That would be 7 pi over 4 plus 2 pi. 7 pi over 4 plus 8 pi over 4 is 15 pi over 4. Okay, so now I've done my second trip around the circle. I've got to do one more trip to get my answers in the range from 4 pi to 6 pi. And again, I'm just going to get the previous answer. For instance, I'm going to get 9 pi over 4, and I'm going to add 2 pi. So that's 9 pi over 4 plus 8 pi over 4, which gives you 17 pi over 4. And the same with the 15 pi over 4 plus 2 pi. 15 pi over 4 plus 8 pi over 4 gives you 23 pi over 4. This stuff over at the side was just, you can do that in your head if you want to. It's not important in your work. So a lot of people can do that in their head, except I've just forgotten what it was. Oh, it's 15 pi over 4 plus 8 pi over 4, that's 23 pi over 4. Have I finished the question? Look to the start of that line. Okay? What have I just solved for? You need to, writing this theta here at the beginning of the line was incredibly important. If you don't write down what it is you've worked out, then you're going to get lost in these problems and you're not going to know what you've solved for. We were just solving for theta, and we know from the beginning up here, theta is 3x. The problem actually wants me to solve for 1x. So to solve for 1x, to cancel out multiplying by 3, I'm going to have to divide by 3, divide by 3. Now think about it, when you're dividing by 3, am I putting 3 in the numerator or the denominator? Yeah, if you're doing pi over 4, if you want to divide it by 3, please don't do that. Don't put these double fraction bar lines. It's really making the math more difficult for you. If you're dividing by 3, just ask yourself, does 3 go in the numerator or the denominator? Well, if you put 3 in the numerator, you're multiplying by 3. You put 3 in the denominator, you're dividing by 3. So when I do this dividing by 3 on all of these ones, oops, let's just delete all those. All that's going to change is the denominators. My denominators are all going to be changing to 3 times 4. All the denominators are going to become 12. So I've got pi over 12, 7 pi over 12, 9 pi over 4 divided by 12. No, what I said there was wrong then. 15 pi over 12, 17 pi over 12, and 23 pi over 12. That's your final answers. Okay, keep track on what you're doing by writing out what it is you're working out, not just a list of answers. Okay, so that was our warm-up. Any questions on that for now? Anybody got a question so far? Okay, let's move on to the next problem then. That's the one we just done. Let's do this now. Ooh, haha. This is clearly a more complicated problem. The first thing we're going to have to do is solve for our trig function. So we're going to do some work till we get sine of whatever we decide to call the angle equals, and we're going to solve for that angle. So we're a long way off that yet. Let's just do one substitution to start with. This is a multiple angle. It's really going to help you if you get rid of that multiple angle. So we've got, and it's something that's quadratic. Remember when you have any polynomial where you've got trying to solve anything raised to a power. Step 1, make it equal 0. Step 2, find the zeros by factoring. Okay, then we can solve each factor. That's what we're going to do here. So we've got 2 times sine squared of, instead of 2x, I'm writing theta. Now I want to make it equal 0. So I'm going to subtract 1, and I'm going to subtract the sine of theta there. And the sensible one of those to write first is minus the sine of theta minus 1 equals 0. So remember, when you've got something that's quadratic or cubic or to the power of 4, try and make it equal 0, then factor it, and that's how you're going to find your solutions. So it's probably going to be 2 answers here because it's quadratic. Let's factor that. Now, if you can factor that straight away with the word sine in it, that's great. If you can't factor it with the word sine in it, because that's really putting you off, you could do a substitution. You could say, let's choose another letter. Let m equal the sine of theta. And our problem now is simply 2m squared minus m minus 1 equals 0. I've replaced the sine of theta with m. Some people are going to find that one easier to factor when it's written like that. So take a second to factor that. So we've got those factors there. Now remember, those are really standing in for, here, I'll move this stuff down here. Doing this substitution in pink was optional. You didn't have to do that. Some people can go straight to factoring with the word sine in it. That's good. So m was standing in for the sine of theta. So I've got 2 times the sine of theta plus 1, sine of theta minus 1. Now I have to solve for each factor. The first factor gives me the sine of theta equals negative 1/2. My second factor gives me the sine of theta equals 1. So now I've got 2 solutions to look at. The sine is y divided by r, and it must be the y that's negative 1. So y is negative 1, r is 2. That's a 30, 60, 90 triangle there. The third side would be the square root of 3. This angle here is the 30 degrees. So my answers for theta in quadrant 3, 30 degrees is pi by 6. In quadrant 3, I call that angle 7 pi over 6. In quadrant 4, I call it 11 pi over 6. Those were my answers from 0 to 2 pi. How many times did I have to go around this? Ooh, look, I didn't do it at the top here. I forgot to do this that time. When I did this substitution up here, I should have changed this straight away. So what I'm going to do is I'm going to have solutions from 0 to 2 pi, and then I'm going to add 2 pi to all of them to get solutions between 2 pi and 4 pi. Okay. So those are my solutions between 0 and 2 pi. For my solutions from 2 pi to 4 pi, to get from that lot to that lot, I'm just adding 2 pi. 7 pi over 6 plus 2 pi. You can do this bit in your head if you want to. It's the same as 7 pi over 6 plus 12 pi over 6. 2 pi is equal to 12 pi over 6. So that gives you 19 pi over 6. That's my first solution. That was getting that 7 pi over 6 and adding 2 pi to it. And if I get 11 pi over 6 and add 2 pi to it, I'm adding on 12 pi over 6. So that gives me 11 plus 12 is 23 pi over 6. Okay. This stuff down the bottom was rough work. We didn't really need to write out. You can do it in your head if you like. And have I finished the problem? No. That was just solving for theta. And theta was equal to 2x. So I'm going to have to now divide every answer by 2 to get my answers for 1x. If I'm dividing by 2, I'm going to double the size of the denominator. Okay, so now I've got 4 solutions there, but look, this dotting down the page, that was reminding me I've only solved for 1 factor. At this point, those were the solutions for this part. Now I've got to look at this one. Okay? Sine theta equals 1. That could be written 2 ways. Turn it into a ratio. It's either positive 1 divided by positive 1, or it could be coming from negative 1 divided by negative 1. And a sine, as we said before, is a ratio of y divided by r. So it can't be this, because r is not going to be negative, okay? So my y is a plus 1. Oh, this is quadrantal, because the length of y is the same as r. So when it's quadrantal, I don't draw a triangle, I draw a circle of radius 1. And the question you're asking yourself is, where on this circle are there points? Might be 1 point, might be 2, with a y coordinate equal to, we said our y was plus 1, not minus 1. Well, there's only 1 point with a y of plus 1, and that represents this angle. And the angle we're solving for, look up at your work, see what you'd named the angle at that point. It's really important to keep track of what angle you're working with at that point. Theta is pi by 2. That's my solution from 0 to 2 pi. I'm kind of looking across at my work over here to keep track of what I'm doing. I'm also going to need a solution from 2 pi to 4 pi. So I'm going to have to get that pi over 2 and add on 2 pi to it, which is like getting pi over 2 and adding 4 pi over 2. So that's going to give me 5 pi over 2. Those were my answers for theta, and theta is 2x. So I'm going to do what I did on the other one. I'm just going to get every single answer there and divide it by 2. Pi over 2 divided by 2. Remember I said I don't want you to write it like that. It's a terrible way of writing it. That's like pi over 2 dividing by 2 means multiply the denominator by 2. So that's giving us pi over 4, and the second one would give us 5 pi over 4. So here are all my solutions to that problem. I've got these 4 from that one factor, and these 4 from the other factor. Now check to see if any are extraneous. our original condition we were given is that our angle X had to be less than 2 pi. That was the original condition. They had to be positive, they had to be bigger than 0. Well, all our answers are positive angles. Are they all less than 2 pi? Well, 2 pi is the same as 24 pi over 12 or 8 pi over 4. Look at your biggest angle. 23 pi over 12 is definitely less than 24 pi over 12. 5 pi over 4 is definitely less than 8 pi over 4. Okay, I was just writing equivalent fractions for this bit at the end. That's all I was doing. Okay, how are we doing now?
Miss Beck.
Mm-hmm.
So
let me pause the video for a second, okay? You have to put you've got to give me the answers. Right, we're now going to do, oh, good grief. Let me just, ignore the fact the answers are there, and we're going to delete the work and go through this one. Forgot to clear up my presentation. Okay, so write down that question there. Looks horrible, but it's really not as bad as the other ones. Looks worse. So what we've got here is we've got the square root of 3 times the tangent of a half angle. We don't want this. This thing, oh gosh, no. Let theta equal x over 2. So what we're looking at here is the square root of 3 times the tangent of theta. That makes it look like an easier problem. But if we're putting in that substitution, we want to know what theta has to be less than. Well, theta is x over 2, so I have to divide that by 2, divide that by 2, divide that by 2. 0 divided by 2 is this 0 here. X divided by 2, that gives me this theta. 2 pi divided by 2 just gives me pi. So even though this question looked more difficult, look what this means. It means I'm only looking for solutions from 0 to pi. I don't have to go around this thing lots of times. I only have to go around it half a time. It's nice. Okay, so let's solve this. Now we're gonna solve this for the tangent of theta. Okay, we're solving for the tangent of theta, so don't square to get rid of the square root of 3. Square root of 3 is just a number. What we're actually going to get rid of here is this multiplication. Remember, to cancel out multiplication, you divide. Now you could rationalize the denominator and get that, but would that be sensible? No, it's a terrible idea. No. Okay? Because we know that tangent is a ratio of y divided by x, and these sides that we have here are sides of a 30, 60, 90 triangle. Now, tangent being the positive ratio 1 over root 3 could come from +1 over plus root 3, or it could come from -1 over minus the square root of 3. Okay, those are both going to give me a positive ratio. Why I've done that is it should remind you tangent is positive. Tangent is positive in quadrant 1 and in quadrant 3. My y is either +1 or -1. That's your y-axis. So it's either +1 or -1. And my x sides are either square root of 3 or negative square root of 3. Those are 30, 60, 90 triangles, where the angle that's sitting at the origin is the 30, which we know as pi by 6. So let's write out our solutions. I'm deliberately going to do something wrong. In quadrant 1, my solution is pi by 6. In quadrant 3, my solution with a reference angle of 6 would be 7 pi by 6. Just open your microphone and talk. Who can see what is wrong with what I've written there? Anyone? What is wrong is
it's over a half.
No. What is wrong with my work there is I haven't said what I've solved for. And if you don't write out what you solved for, then you don't know when you finish the problem. What goes to the left of that equal sign? Look up here. What angle was I solving for? I was solving for theta, yeah? And I don't want to solve for theta. I want to solve for x. So what's the relationship between theta and x? Theta, that was the substitution, we said was x over 2. And what did we say about theta? I was only looking, when I was solving for theta, I was only looking in the top half. So I don't need that one, don't need it. I don't need anything from quadrant 3 or 4. Now I want to solve this for x. X at the moment is being divided by 2. How do you cancel out divided by 2? You multiply by 2. You put 2 in the numerator. So x would be 2 pi over 6, which is pi over 3. Oh, and that was all. That's the only one we needed. If we'd left that one would have become 14 pi over 6. And can you see that our original condition for x was 0 is less than equal to x is less than 2 pi. And this is too big. It was easier to just cut it out at this point, saying I'm only looking for ones for theta between 0 and pi. Okay, that was that one. Right, we've got one more to do, and you've got about 7 or 8 minutes. You need to, every single person, this is a grade. You have to type into chat. Oh, I don't know what happened to my camera. I'm sorry, guys. I didn't notice my camera went doolally. Here's this next problem. I want you to solve this. Come up with your solutions. You don't have to bring it to me to grade. It's not a warm-up, it's a closing task. You need to type your answers into chat. This is probably going to have you're going to have to go 3 times around. You're going to have to go up to 6 pi. It's probably got 2 answers in each rotation. So you've probably got 6 answers you're typing in for me. Off you go. When you've finished it, you can leave the Zoom class, okay?